Hi and welcome to this RIPEX tutorial where we're looking at radio parameters. Before guiding you through the configuration, let's discuss some radio communication basics and requirements to legally operate a licensed radio network. If you're familiar with the theory, please feel free to skip directly to the step-by-step configuration section using the link in the top right corner of this video. RIPEX is designed for VHF and UHF bands from 135 to 960 MHz across the models in the product line. One radio hop is typically 5 to 50 km, but possible up to 100 km, including near line of sight or non-line of sight environments. Since an unlimited number of repeaters is possible, the coverage footprint is unlimited. RIPEX uses licensed bands. If you want to operate the unit in the field, you need to have a license from the respective government body in your country. The minimum number of parameters listed on the license would include frequencies, RF power, and channel spacing. In many cases, it would also list occupied bandwidth limit and modulation. If you don't have this license yet, you need to obtain it. We are happy to provide information to support your application. Since licensed frequencies are used, the network is private. The user has it under his full control and is therefore not dependent on third-party services as in mobile cellular networks. That is why constant response times and availability are always guaranteed. RIPEX is specifically designed to operate reliably in licensed bands, making it a great radio modem for mission-critical SCADA and telemetry applications. Its licensed radio band and industrial build quality deliver reliable communication for systems that must not fail. Now let's get started. All you need is a RIPEX unit, a device to configure the setup, the license you obtained from the local regulatory office, and a few minutes of your time. Please connect to the unit via its current IP address. It is supposed the unit is in the factory settings, so the default IP address on all Ethernet ports is 192, 168, 169, and 169. Or you can use the USB to Ethernet or USB to Wi-Fi adapter using the IP address 10, 9, 8, 7 with DHCP enabled. The default access credentials are admin as user and admin as the password as well. Click on the login button to start the configuration. If any parameter you want to set is not active or visible, the required software key is missing in your unit. For more information about software keys, visit the Racom website or contact us. After logging into the device, go to Settings, Interfaces, Radio to access all radio parameters. TX and RX frequencies are set in Hertz. The minimum tuning step is 5000 Hz for 25 kHz channel spacing and 6250 Hz for 12.5 and 6.25 kHz channel spacings. The value entered must be within frequency tuning range of the unit, otherwise the unit shows a warning and will not save it. In most cases, half-duplex mode is used. In this mode, data is transmitted in both directions, but not at the same time. So TX and RX frequencies can be the same. In certain cases, the regulatory office grants a frequency pair even for a half duplex, and TX and RX frequencies are different. If this is the case, remember that TX and RX frequencies must be switched in the second unit on the opposite side of the link. Full duplex mode allows data to be transmitted simultaneously in both directions. In this case, a frequency pair must be used. One frequency for TX and one for RX and vice versa on the opposite side of the link. When one frequency or a frequency pair in half-duplex mode is used, the antenna configuration should be left in the default setting, which is single. because typically one antenna connector is used. In the case of full duplex operation, dual setting is mandatory. If you use dual mode, either 2 antennas or a duplexer must be used. For more details, watch our full duplex point-to-point link tutorial video. The next parameter is RF power PEP, which stands for output power on radio channel defined in peak envelope power. You may be familiar with the RF power RMS, root mean squared value, used previously. Nowadays, PEP is preferred because in case of high-state modulations like QAM, it more accurately reflects the reality. In case you need RMS values, please refer to the embedded help notes or have a look at the conversion table on screen. Channel spacing and occupied bandwidth limit influence the maximum possible data speed. Simply put, the wider the bandwidth, the higher the data speed. Channel spacing is always defined in the license. Occupied bandwidth limit requires 99% of energy to be within defined range, and it is usually also given by local authority and cannot be exceeded. Possible values and related data speeds can be found in the RIPEX user manual. Set channel spacing first, and a list box of occupied bandwidth limit will offer applicable values. If an occupied bandwidth limit is not defined in your license, set the widest one so you can enjoy the highest possible data speed. RIPEX supports 2 modulation types. FSK, a frequency modulation, is more robust, provides higher sensitivity and interference immunity, but lower data speeds. It is great for longer radio hops, non-line-of-sight links, or locations with high radio interference. QAM, linear modulation, is less robust and more suitable for general conditions. It provides higher data speed. Modulation depends on selected modulation type, and the user interface offers only relevant choices. In general, the higher the modulation, the higher the speed, but the lower the interference immunity. Exact data speeds for individual modulations and respective channel spacing can be found in the user manual. Forward error correction, or FEC, is a very effective method to minimize radio channel impairments. It operates on a simple principle of adding redundant data into its messages. The redundancy allows the receiver to detect and correct errors. The improvement, however, comes at the expense of user data speed. The lower the FEC ratio, the better the capability of error correction, and the lower the user data speed. You can calculate the user data speed by multiplying the modulation rate by FEC ratio. In the modern environment, security is a critical part of communication design. All data on the radio channel can be protected from an intrusion using standard AES-256 CCM encryption and authentication. When encryption is on, 25 bytes overhead is added to the encrypted data whose length is the same as the original data. A 256 bits encryption key can be generated automatically using the passphrase of up to 128 ASCII characters, or you can input your own key of 64 hexadecimal characters directly. Of course, the encryption key must be the same in all units in the network. The last step is to apply the changes. Although the RIPEX settings have been changed, these changes have not yet been saved. In the top right corner, click on the Changes button. A new page appears. It summarizes the changes against the current settings. Check the changes you have made and whether all parameters are in accordance with the license. Then, click on the Send Changes button. When the confirmation message is displayed, you have successfully set up the unit. And finally, log out of the unit in the upper right corner. Thank you for watching this Ripax tutorial. If you need any more information or support, please get in touch with us or send a support request from the support section on our website. And remember, please subscribe to this channel to stay up to date with our latest tutorial releases. Thank you and have a great day.